Hi students, if you like my channel, please press like button and subscribe my channels and share with your friends. Okay, today we are going to discuss about the types of solution based on the concentrations. The solutions are classified based on their concentrations. Okay, let us see how the solution is classified based on their concentration. It's a very simple process, and every day in our day-to-day activities we apply it unknowingly without knowing the real concept of this. Okay, so I will tell you how we apply it. So example, if you see, if you keep the dry seed in the water, and what happens to the dry seed? And the dry seed bulges out. Am I right? If you keep any fruits under the sunlight, what happens? The fruits are dried up. It is not that however you keep the fleshy fruits under the sunlight, it will not be. So after dried, it will shrink its size. Okay, so these things and all we apply in our day-to-day life without knowing the science fact from behind it. So let's move on. So examples, we add salt also to the substances. Okay, why we are adding to the fruits? Sometimes when you add salt to the fruits, what will happen? Okay, so all these things are the science fact, but we do not know how it is working out and what is the principle behind this all day-to-day activities. So let's discuss about the types of solution based on its concentrations. There are three types of solutions identified. There are three types of solutions identified based on their concentration. Number one is called hypertonic solution. Hypertonic solution. Hypertonic solutions. So hyper means high. Okay, tonic means solute. The meaning of tonic, solute. In this solution, the water potential is very low. Low water potential and low solvent and high solute molecules are present. So in hypertonic solution, water potential is very low and very low solvent, but high solute molecules are present. So thereby what will happen? These solutions will attract the solvents from other solution. So hypertonic solution will attract solvent from other solutions. Okay, so they attract solvent from other solutions. I will explain how it will be. Okay, next thing is an hypotonic solution. In case of hypotonic solutions, what is this kind of solutions contains high water potential, high solvent, okay, but low solute. So hypotonic solutions contains high water potential and high solvent but low solute molecules. Okay, so that way these kind of solutions they diffuses out to another solution. So they diffuses out to another solutions. Okay, so another third one is an isotonic solution. Isotonic solution. So in case of isotonic solution, the movement of substances from the inside of the cell to outside of the cell are equalized. Nothing will enter. Nothing will enter from outside to inside. Nothing will go out from inside to outside. So that the net movement is always zero in isotonic solutions. Okay, equalized. The concentration of solution inside the cell, outside of the cells are equalized. So thereby it shows an equalization. So net balance, net value is zero. Okay. So let's move on to that what will happen to the cell when it's placed in these kind of solutions. Okay. So let's take that hypertonic solutions. When a cell is placed in the hypertonic solution, what will happen to that? When a cell is placed in hypertonic solutions, what will happen to that? This is an external solution. This is an external solution. Okay, so hypertonic solution. Hypertonic solution. What is the nature of hypertonic solution? What is the nature of hypertonic solution? So this hypertonic solutions value low water potential, okay, low solvent and high solute. That is a nature. So in hypertonic solution, the external solutions contain low water potential and low solvent and high solute molecules. Am I right? So check the cells, consider here. This one will be having so here look at this diagram, and this is an external solution. According to the external hypertonic solutions, we are having that high solute molecules, then low water potential and low solvent. Okay, inside the cell you are able to see that water potential is -1 and solute potential is -1. Okay, then the pressure is normal. Okay. So pressure potential is 0 here and outside. What will happen now? So outside this external solutions having the high solute molecules, okay. So external solutions is having the high solute molecules. So but the low water potential and low solvents. Okay. So thereby what will happen, and it will attract the solvents to the surroundings, to the other solutions. So it attracts the solvent to the other solutions. So thereby, so the water molecules comes out. The water molecules comes out of the cell. The water molecules comes out. Okay. The water molecules. So when the water molecules comes out of the cell, what will happen? The cell started to shrink. Okay. First the water molecules come out of the cytoplasm, followed by the vacuoles of the cell. Okay. So once the water molecules come out of the cell to the external solutions, so the cell size is changed. That means the cell started to shrink. Move cytoplasmic content, shrink, move away from the cell wall. This conditions we call it a flaccid condition. This is we call it a flaccid condition. Okay, this is we call it a flaccid condition, shrinkage of the cells. Okay, this shrinkage of the cells, and we call it a plasmolysed cell. Plasmolysed cell. What is meaning of plasmolysed cells? Plasmo means plasma. Okay, lysed means breakdown of the plasma membrane. So plasmolysis. Flaccid cells lead to the condition called plasmolysed cells. This process is known as plasmolysis. This process is known as plasmolysis. Okay, so do you understand what happens to the cell when it is kept in the hypertonic solution? When a cell is normal cell is kept in the hypertonic solution, the cell started to shrink in its size because of the exosmosis. What is exosmosis? So based on the direction of the water molecule into the cell, outside of the cell, osmosis is classified into two types. One is endosmosis, another one is an exosmosis. The exit of the water molecule from the cell is known as exosmosis. Okay, the entry of the water molecule into the cell is known as endosmosis. Okay, in hypertonic solution, when the cell is placed and the cell started to shrink, that means these water molecules go out of the cell. Okay, to make it an equilibrium to the external solutions. So thereby the cytoplasmic content shrink and move away from the plasma membrane. Then what happens? These plasma membranes are move away from the cell wall, leading to the flaccid condition. Flaccid condition of the cells finally lead to the plasmolysed conditions. So this process is known as plasmolysis. Okay. So next thing we'll discuss that hypotonic solution. What will happen to the cell when it is placed in the hypotonic solution? So this is a diagram of that hypotonic solutions. The external solutions are hypotonic. Okay, so we already know what is an hypotonic solution. The solution in which that water potential is higher, high water potential, low solute potential. Okay, solvent is more, solvent is high solvent, high water potential, low solute potentials. Okay, look at this diagram. Look at this diagram. This is an inside the cell. The water potential is denoted as -1, and that solute potential is denoted as -1. Then that pressure is 0. Okay, but outside of the cell, the water potential is denoted as 0. Okay, then the solute potential is denoted as 0. Clear? And that pressure potential is denoted as 0. Clear? So look at this, what will happen now. So since that the external solutions in external solution have high water potential and high solvent and low solute, so what will happen? Then the diffuses, the Dolly solution diffuses out into the cell, diffusion out into the cell, diffusion out into the cell. Diffuses out into the cell. Since these solutions has high water potential, high solvents and low solute capacity, and the solution diffuses out into the other solutions. So the water molecules enter into the cell and thereby the cell became bulged out. So the cell absorb more water molecules and bulge out. Okay. So what will happen if it's bulge out? So due to the absorption of more water molecules in the cytoplasm, the cytoplasmic content give pressure against the cell wall. The pressure given by the cell membrane or cytoplasm is known as an turgor pressure. Turgor pressure. The cell content of the cell give pressure against the cell wall. That pressure we call it a turgor pressure. Okay, in order to balance this, equalize this turgor pressure, the cell wall also started to apply the pressures against the turgor pressure. So that's we call it a wall pressure. Okay, so the wall pressure and turgor pressure make the cell turgid. A wall pressure and turgor pressure make the cell turgid conditions. Okay, so this turgid condition. So when under which condition the cell may burst out? Either if the turgor pressure increases. If turgor pressure increases, then the wall pressure, then automatically the cell burst out. Okay. If the wall pressure increases, then turgor pressure, then the cytoplasmic contents will be shrunken too much. Okay, so whatever it is. So thereby, in order to avoid the bursting out of the cell, the two pressures are acting on each other to equalize. One is in turgor pressure, another one is in wall pressure. Okay, one is in turgor pressure, another one is in wall pressure. Both are acting on each other and maintain the stability of the cell. Okay. So when a cell placed in the hypotonic solution or pure water, the cell bulges out. Okay, and the water from the external solution diffuses, enter into the cell, making the cell enlarge. Okay, clear? That's good. So now I am going to introduce two terms. One is in plasmolysed condition and deplasmolysed condition. Plasmolysed cell, deplasmolysed cell. So what is plasmolysed cell? As I already told, when a cell is kept in the hypertonic solution, the cell shrink in its size. Okay, the cytoplasmic contents move away from the cell wall. So thereby the cell is shrink in its size. Okay, this condition, this cell is known as flaccid. If it continues further, okay, then it is called as a plasmolysed cell. The process is known as plasmolysis. The process is known as plasmolysis. How can we bring back the plasmolysed cell into the normal cell? How can we bring back the plasmolysed cell into the normal cell? Okay, so when we keep this plasmolysed cell in hypotonic solution or pure water, so these plasmolysed cells will bulge out and becomes the normal cell. What is the significance of plasmolysis? What is the significance of plasmolysis? So plasmolysis is very important to know that whether the cell is alive or dead. Plasmolysis process will act on only the living cells, not the dead cells. Okay, so the plasmolysis process act on only living cell, not the dead cell. Thereby this plasmolysis helps to identify living cells and dead cells. Okay, so do you understand? So bring back the plasmolysed cell into the normal cell. That process called deplasmolysed cell. That process called deplasmolysis. The cell is known as deplasmolysed cell. Okay. Thank you for watching my channel, and we will see the remaining things in the next class.